Hello, I'm Alex, and welcome back to Simply Space. Today, we will be talking about the Cosmic Microwave Background, or the CMB. While the name may seem daunting, when we are done with this video, you will realize that it's not all that complicated. We will be breaking down this topic into 4 subtopics: who discovered it, when and how it came to be, what and where it is, and why it is important today. First, we will discuss the discovery of the CMB. I bet you didn't know that what we now know as the CMB was originally thought to be interference from pigeon droppings. The CMB was discovered on accident by physicists Arno Penzias and Robert Wilson. They were using the Holmdel Horn antenna, a super-sensitive radio telescope, to study radio signals around the Earth, and took all necessary precautions to avoid outside interference. For example, they removed the effects of radar and radio broadcast. They even accounted for heat interference in the receiver itself by cooling it with liquid helium to negative 269 degrees Celsius, only 4 Kelvin above absolute zero. Despite all these precautions, they still detected what seemed like an error. There was a low and steady wavelength that was 100 times stronger than anything they expected. They immediately began investigating their telescope for the source of this signal. From this investigation, they noticed pigeons nesting in the telescope and blamed them for the interference. But even after a thorough cleaning, the noise persisted. They concluded that it was not from our solar system, or even our own galaxy, for the signal was uniform in every part of the sky. But they left their research there, confused about what this strange signal was. It would be many years later that scientists would realize what they had actually observed. Now I bet you're still wondering what exactly the CMB is. Put simply, it is a shell of radiation that surrounds the observable universe. The radiation is primarily in the microwave range, hence the microwave and cosmic microwave background. The CMB is the leftovers from a time when the universe was very hot. At this time, all matter existed as a hot and dense plasma, so much so that the universe was opaque. However, around 380,000 years after the Big Bang, the universe cooled enough for protons and electrons to join, forming atoms and freeing photons. And then the universe became transparent. As I mentioned earlier, the CMB exists as a shell of radiation. Since it is so dense, it is impossible to see through it. Imagine the room you're in. The walls are like the CMB. You know there's something outside them, but you just can't see it. So yes, scientists' attempts to view the universe at a time before the formation of the CMB have been foiled by the same thing you use to reheat your leftovers. Now, the CMB is very cold, only 2.725 degrees above absolute zero, the coldest possible temperature where there's no atomic motion. It is also a nearly uniform temperature. If we could see microwaves, we would see a uniform glow across the whole sky. Other than being a viewing barrier, the CMB is a valuable tool for scientists. In 2013, the Planck satellite was launched to map the CMB, creating the clearest rendering yet. The temperature differences are extremely small. Only 0.0002 Kelvin separates the hottest and coldest temperature. But in these minute temperature differences, scientists have been able to make theories about the universe prior to the formation of the CMB. The CMB is a catch-22. While it blocks us from directly viewing the universe at the year 380,000 and before, it is our only tool to understanding that time. Thank you for watching our video on the cosmic microwave background. If you want more information on anything we discussed today, please visit our website by clicking the link in the description below. If you liked this video, please like and subscribe to Simply Space, and we will see you next time with a new space topic to simplify.